Wow, thank you. There's a gap over here. I think it's because I was sitting there and everybody's like, you've got to be 10 feet away from whoever's speaking. Right, okay, so just let me get going. Okay, right, so this is going to be fun. So I've had my eyes done, which means that I've gone from being long-sighted, short-sighted to being long-sighted. So that whereas it used to be when I used to do this, I could read exactly what was on the screen, but I couldn't see you. Now I can see you, but I can't see what's on the screen. So if I'm doing this, it's because I can't read what I'm doing. Okay, well, let's get going. You can see from the T-shirt, I used to work at IBM. I did JVMs. That was how not quite what I got to IBM for, but I've been doing JVMs since before it was one, when it was down here. So I've had fun on all sides of this, and I've also done other things, like I ran a DevOps team for a few years, and so I've learned lots of stuff on all sides of the fences. But Java is what I keep coming back to. So this talk is about APIs. It's about Java APIs. It's not about REST APIs. Cool, you're still here. So how many people here are Java developers? That's good. There's a lot of people who haven't put their hands up, which is a bit scary. Okay, I've got 40 minutes, so there's a lot to go through, so I may move things around depending on how I feel to try and get some of the messages across. It's complicated, but we want to look through why things are not as good as they could be, look at how you do things, and see whether you can do them better, and just touch on some of the new features that are around, or newish features that are around, that you may not have heard of, or you may have heard about and not used. Right? What I want to do is just get you thinking a bit more about how you write Java code. So if you've had any teaching about how to design Java, you may have come across the word solid. Solid stands for something I'll show you in a second. Or you may have looked at the Java doc for Java and seen things like the UI things, the UI classes. So your influence on how you're influenced on how you write Java sort of depends where you started, but quite often it's one of these two places. You look at how people write code already, or maybe you get some more structured approach. So you can go read about solid. I'm not really going to touch upon it because I don't have time. There's nothing in here that's particularly damning. It's all good stuff. You can go read this and maybe you'll spot some of the design principles you're following through now. There's lots of good stuff about how you should write good APIs, which are applicable to everything, right? Not just Java, right? From my point of view, there's a flaw, right? Not in what they say, but in the fact they don't go far enough. All this is great when you're writing APIs now, but it's like, what do you think about when you design the API for tomorrow? How much you put into your design so that when you get the inevitable change tomorrow, you're able to deal with it? Can you evolve these APIs, based on unexpected requirements? Now, it's really hard to do that. Right? Whenever you write code, you always end up with things that you find out later were a mistake because you didn't think that was going to change. But what I want to show you as we go through some examples of where you're already doing that and you should just not do it because it's a mistake anyway, and show you some of the things that you could do using Java to think differently about what an API is. Okay, so we have challenges getting where we want to go, right? So if the Romans wanted to go to the moon, they wouldn't think about building a rocket. They'd think about, I don't know, some enormous tower. Their thinking is different. So when a requirement comes in, based on what they're thinking, they'll implement it that way, right? So I want to get you to just think differently, right? So the first thing is that, don't worry, nobody gets this right. So I used to work for Sonotype, who are the guys who run Maven Central. And we just did a basic study going, if you look at semantic versioning, which are the three things you're aware of, major version, minor version, patch version, 1.1.2 or whatever, we said how often when you download something, how often is it going to break you? Can you predict breakage based on the version number. So if the major version changes, you think, oh, maybe it'll break, right? If I go from version 1 to version 2, there's an intent in semantic versioning to tell you things are broken. So you would expect that. If you change the minor versions are supposed to be new features, not breakages, right? And then patch versions, the third dot, is meant to be bug fixes, basically. You don't release new code, you just bug fixes. So you can expect that if the major version changes, it'll break. If the minor version changes, it shouldn't break. And if the third one changes, it shouldn't break at all. Well, it turns out that generally, distribution of breakages has nothing to do with semantic versioning. Whatever version number, whatever you think you download is, there's a pretty good chance it's going to break you. Right? People update patch versions and they break you. People update minor versions that break you, and people update major versions and break you, or don't. Right? It's really, really hard, apparently, for us to communicate our intent. Right. So that's the first takeaway. When you look at downloading stuff, we'd love you to feel that semantic versioning is something you can rely on, but the end result is it's all up to you to figure out. Right? You can't make any distinctions. You just have to test it. So we have to ask ourselves why that's the case. And there's a bunch of reasons why it's that case, whether that is the case. A lot of the time it's because you don't realize you're breaking the API. And that's one of the things I want to focus on. Other reasons, like you did it deliberately, fine. That's your choice. But there's a lot of stuff where we break APIs because we didn't realize that we were doing it, or we painted ourselves into a corner very quickly and didn't realize that the first go around. So can we do something about that? Right. So it starts with the IDE. If you look at how we use IDEs, right? We look at IDE time as against compile time or runtime. IDEs are great. Love IDEs. Who would not? Let's do a thing for JetBrains. Who's using IntelliJ? Okay. Who's not using IntelliJ? Okay, so hardly anybody. Okay, so there's your hint. Okay, so this is all IntelliJ stuff. Is anybody from IntelliJ here? I'm promoting you. No. Okay, right. IDEs are great. You know how it happens. You put up some code. And here's an interface called tree streamer. It has a method that returns a stream, and it tells me that I'm using a raw use of a parameterized class. Stream, not tree stream. Right? I'm returning a stream. But I could do better, right? So the IDE can help me. So all the stuff in gray that you know is not part of the language. It's what the IDE is telling you in situ help. Build.stream says, hey, returns a stream of objects. And then I've got a map, which returns, well, I cast it to a file. Okay, maybe that's good or not so bad. But at which point, the IDE picks that up and says, no, it's a type of stream, of file, and then I can run the filter. Right? If I make this change at the bottom, if I genericize my implementation with the F, right, I can now implement something that means that I don't need to do that mapping in the middle. I don't need to convert an object to a file. Right? I'm only doing that because it stops the warnings from IntelliJ. Right? So I can do that. And now I have a cleaner code. I've got build.stream, returns stream.file, and I can now have my filter. So it's great, right? The IDE has helped me spot something I could do better. I've implemented it. Great, right? It sounds good, but it's sort of good, but it's got edges. So let's see if we can read this through. So there's the genericized class at the top, right? And here's this class in the middle which implements it. It returns a stream file. I mean, it's silly, it's an empty file, but it returns a stream of those. So you'd only get one file. But there's my code that's genericized. But somebody else could do things differently. So look, I have the stream file. I have some piece of code that returns a stream with type file. And embed that is a horrible piece of code that instantiates another streamer and streams hash sets, the content of hash sets. Right? Now, that's an object. Well, it's going to be empty because the code doesn't actually return anything, right? But I get warnings from the IDE, but it's perfectly valid code. Right? The IDE tells you that the compiler is warning you that maybe this is not a good idea, but it's valid. So the idea that this enforces anything, right? Don't believe that, right? So when you do this and you think that you're using genericized things to filter out and get the objects that you need, it can actually bite you because somebody else may just have ignored it, right? So often you might have to put that filter method in just to filter out the things that aren't the type that you think, even though in theory you're never going to get them, right? Generics, which are really great for helping you design code, can bite you at runtime because you have this thing called type erasure, where that information is basically lost. The compiler doesn't care. The compiler would tell you off. Runtime certainly doesn't care. Okay. Now, the other thing the IDE can do for you is it's really good at helping you refactor. So when you change code, you may break your downstream users inadvertently because when you use the IDE to refactor, it refactors your test cases, everything, and everything compiles and works, and you think, hey, I've done it. Right? In a single module environment, that's like life. We do that all the time. Okay? When you refactor code, you have to be certain that you understand the impact on your test cases. And you can work around this easily. If you're a Maven user, I suspect this is Gradle, work for Gradle too, but I've not used it. It's actually very simple to have version 1 and version 2 around, follow the right paths. That wonderful piece of XML on the left is the test plugin, but you have this thing called class path dependency excludes. So you can actually set up a class path in Maven with all of version 1 and version 2 and whatever you've got. And at test time, you can say, well, I'll have that whole class path, but take that out, take that out, take that out. So you can easily set up an environment to test your new code against your old tests, provided you package and install them locally, right? If you don't do this, if you don't have a version-to-version testing strategy, anybody downstream of the APIs you make available, whether you're publishing them Maven Central or using them internally, you may break inadvertently because you're inside that echo chamber of your IDE. Okay? So it's a be warning. Okay. Right. Now, I want to just talk through this just a little bit because, again, it makes a difference. Quite often as a Java developer, this doesn't mean anything to you. You write Java code and it runs. But there are layers. You've seen what an IDE tells you stuff, which is great. Compiler may warn you. It's not so good. And at runtime, other things will happen. So when you have your code, you have your API and you have source code and you compile it and you get files. And then those files get used as a dependency in somebody else's build process. Right? The compiler enforces what's called the Java lang spec, the document that tells you this is valid Java. Okay? When you run it, the rules in that class spec is for how to construct, how to parse Java code and create a class file. The JVM doesn't quite understand classes the way that you do. And then when you put classes into the VM, when you stack on the class path and run things, the JVM enforces its own rules. Right? And the way that it interprets class files and classes is different from what you might think. Right? Most of the time you won't notice, but it can bite you. So I want to have a little conversation with my audience here about this. Let's look at audience participation time. Right. So this scene. Here we are. We have a JVM. And we have all the dependencies that we might need for our latest version of code. and we have our API, our latest version of code. So the one in the middle is our code. The red box is any dependencies that code needs, right? And sitting on top of that, logically, is whatever our users have written. Okay, so that's the scenario. Let's see what happens. I want to ask you some questions, right? You have a method called A, and it's public. If you change that method on your API to make it private, what's going to happen? What's going to happen to your end user? Okay, if you reduce the access, if you change it from public to private, so version 1 public, version 2 private, what happens? Right? Well, at runtime, it will fail because that method is invisible. You've made it invisible. Your API, your customers was calling that, it's now disappeared. You've made it invisible, so it will break. Compile time, it might get away with it depending on what code is being involved in calling that. So you might get away with compile time, but you certainly won't getting it at runtime. So if you change the scope of a method, it will fail. Right, if you make it private. Now, I'd expect you all to know that one, right? That's the test, that's the beginning. Let's try a few more. What happens if you change the return type? You have a method which returns an integer, and you change it to return a double. Who thinks that will break your API user at runtime? Okay, that's good. This is always people going, I'm not sure I know Java. Yes, you do. Okay. What about at compile time? Will it break at compile time? If the Java user of your API recompiles, will it break? Okay. Well, I think you know the answer. At runtime, it will fail. At compile time, you may get away with it, because at compile time, the compiler is good enough to be able to finesse these differences and deal with it for you. But at runtime, that method has disappeared because the signature of the method that it's looking for includes the return type. And now you've changed it. So that method no longer exists as far as the runtime is concerned. It is a completely different one. You could have renamed the method and it would have made no difference, right? Okay. Let's do a couple more. What happens if it was an object that I returned rather than a primitive? What happens? Does it break at runtime? Does it break at compile time? Who thinks it will break at runtime? Who thinks that if I was to make this change and my customer's API, my customer's code called this, that it would break? Who thinks it will break? Yes. Good. So same thing. It's part of the signature. When you change the return type, that method no longer exists. It is gone. There's no fuzziness going on here, right? There's no, oh, well, it's in the same object hierarchy, it should all work. It will fail. The compiler may deal with it okay for you, depending on how it's being used, but at runtime, no method, gone. Okay? What about class hierarchies? Class A, class B, class C, they all inherit from each other. So I have one up here called advanced calculator, and it extends another one called calculator. If I now have a new version of advanced calculator that doesn't extend calculator, right? I've removed that relationship. What's going to break? Will it break at runtime? No, you don't know. Yes, yeah, okay, yeah. Wrong, no. Okay, it depends, right? It depends. Why does it depend? Well, because the runtime, when it looks for methods, looks up the hierarchy. It doesn't care where it finds them, it just looks up the object hierarchy you created. So if you have advanced calculator that extends something, if every method on a calculator is now pulled down to advanced calculator, everything will work because the VM can find it. You see the differences between compile time and runtime. There are subtleties and they break you. Right? What about exceptions? I have a class that throws an exception. I change it to throw a different exception. How does that break? Does it break? It doesn't break at runtime, but it will break at compile time. The compiler is very worried about you dealing with checked exceptions. Absolutely, just like you have to deal with it. Runtime doesn't care. Exceptions are not part of the method signature. There's no mapping of that. That's not what happens, right? I'll show you what happens in a second. Right? The only time when things go wrong is when exceptions are thrown. But compile time, the compiler will tell you off. Runtime, well, what happens at runtime is that the JVM is looking for a catcher. It's looking for the catch in the try block that will handle that method. If there isn't one, then the thing will fail, right? But it's not, there's no enforcement of checked exceptions. They're just exceptions. It's the compiler that tells you the checked exceptions are like that. Right, okay. Right, one more, and I will forgive you if you don't know this one, because this is subtle, and this is irritating, but it can bite you. So I have a version 1 class. If you see it says public static final string my constant equals hello world. Okay? And then I create a new version of this, and I change the constant to be something else. Now, you might have it more intended to be used as some sort of in select statements or something. But anyway, okay. When the user code, right, which prints out constants.myConstants, right, what's it going to print out? Is it going to print out the one from the last version or the one from this new version? Bearing in mind the last version class doesn't exist. It's not in the class path. It's not reachable. All it's got is version 2 and its code. Okay, now here's the horrible thing, right? Is that when you run it, you get hello, right? If you recompiled it and ran it, you'd get goodbye. Because the compiler, in its infinite wisdom, when you use reference primitive static final classes and strings, will take a copy of the value and insert it in your code. So when it sees constants.myConstant, it hasn't actually compiled it like that. It's gone system.out.println, this thing I squirreled away, this piece of value, okay? So if you change static constants, assuming that they're part of some process for determining action, you won't get what you expect because your API user, unless they recompile, will get the old version. It's a really classic one because things go wrong. You don't understand why these are failing. You ask your customer to recompile and the problem goes away. Right? Okay. So I want you to start thinking that compile time and runtime are different. Right? There's not that much difference. Most of the time you're okay, but there are edges and there are things that you have to be aware of when you're designing APIs, especially when you're looking at evolving them. Okay. Okay. So how do you make your APIs a little safer? Well, let's see if we can do this one. This whole idea of having classes, interfaces, and abstract methods and things like that, it's quite old-fashioned. It's turned out to be more painful, more dangerous, more brittle than we really like. It isn't the right way to do it. Modern APIs should be more policy versus process. When you interact with things, interact with, say, a vending machine, right? You press buttons or whatever, you're telling it what policy you want. Select me a Coke, select me a hot chocolate with this, set the washing machine to this, right? You do not get involved in the making. You do not want to get involved in the making, and the people who produce these devices do not want you to get involved, right? Because horrible things happen, right? If you look at the way we used to do it, you'd have an interface on the top left and an abstract class, and then you'd ask your customer to create a concrete version of that. That would be a classic pattern. And you can see the first one's got some methods, the second one implements some of them, though actually the last one, the bottom one should say, no, the bottom one's right. But you can see there's one missing in the middle, get softener. It's not the abstract class because that's allowed. The concrete one has to provide that, which it does. It does whatever it wants. You've just said to your API consumer, give me something, whatever you want. Okay, it returns null, so that you can deal with. But unless you've been clever and made the wash method final, your end user can override that. Your end user can take control of your classes because you allow them to do that. All right? And the relationship between the method you're asking to fill in, the get softener one and everything, and the behavior of the abstract washing machine is not very well defined. Right? When it says get softener, you might go, well, how much water's in the machine? What does the abstract washing machine tell me? Don't know. Can't get the data. Right? Okay, maybe you'll guess. So its relationship is wrong. You're asking it to be part of the machine, and that's not what you need. Right? There are these things called sealed classes, and they've been around since about Java 15, and you can apply them to interfaces and classes. You can see there's some new words, sealed and permits. So the first one says, I'm going to declare an interface called navigator policy, and it permits abstract navigator policy, the one below, to implement it. Right? Nobody else can implement that interface unless I list them there. Okay. So you can see what I've got here. I've got two classes, right? What we're going to use this for is to create a new shape of an API. So I've got interfaces, I've got classes there. They look similar to the old thing, but because they're sealed, I can't have other people creating their own versions of the interface because I won't allow it. So I've got the control of this, right? And then I have builders, right? My builder, which is in this example, uses inner classes to construct a pseudo API structure. So for complex APIs, I don't have to have complicated constructors, I just have builder patterns. The bit at the top says navigator policy builder. Look, it extends this abstract navigation policy. So I'm using abstract in this way so that my inner class doesn't have to have all the code. I can keep all the code in the abstract class. Nobody can instantiate the abstract class, right? And because I prevented that happening. So I can keep my code in good structure. But with this thing, I've got private on this class, so nobody can instantiate it. I am absolutely in control of the class that I need to be in. And the way that I interact, the way that I ask the person to press the button is through builders. Builders are much more flexible and much more changeable. And at the end of the day, you press build and you get the object that you want. You're not asking people to use constructors and things like that. You're just like, tell me your policy. And in this case, I'm actually using these to build a policy, right? This is policy. This is what do you want my code to do, okay? And I might have some lambdas in there. I might have some callbacks, but it's much safer than the abstract class method because I can control it so much easier. So there's a bigger one, but it's so much easier to create API designs using this sort of approach with builders and inner classes, and using sealed classes to give you the lock-in so that you can't prevent other people exploiting you. They can't do what they would do if you use the old pattern. And by separating policy, so the first one you see, it says policy, that comes from the other class you see, and everything else is process. This is where my user code gets involved. I have a policy that I give to the API to say, you do your bit, and then the rest of this builder says, okay, when things happen, here's what code I want you to call. Right? You're not involved in what happens, you're reacting. You use the policy to decide what you want the code to do, and then when you get the data, you can do whatever you want with it, right? It's a much better way of making that separation. So sealed classes, I say Java 15. If you're on Java 8, then hey, you need to move up, right? This stuff is really cool. It makes a big difference. Right, what else are we going to talk about? So let's go back to some catches. There are other little tiny things. I told you there are things that we do on APIs that you just go, I just wish I hadn't done that. Okay. Oh, stop. So we've got 10 minutes? 10 minutes, yeah, okay. Okay, my phone is more eager for me to get off than everybody else. Okay, so version 1, public short get int. The number of times you go, oh, the range of the value I'm giving back is just going to be between 1 and 10. And then the next thing you know, you go, okay, I need it to be longer. You can't change that without breaking your APIs. Okay? But that's really because we overload primitives with meaning. We go, okay, so that thing I'm using that looks like a number. So we'll store it in a number. Right? But that's really bad. You have strong typing, right? You can create types of ID. It doesn't cost you anything, right? Apart from a few lines of code. And then you can evolve it. And so at the point when it stops being a digits and you want alphanumeric in there, then you can deal with it, right? 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 And it's the same with strings. So often people use strings not as a label, but with intent, with meaning. It's a postcode, it's a zip code, it's whatever. And it's like, no, it isn't. It's a string. Use it as a label. Have a type that represents the thing you want. Certainly have methods on it to bring back labels, like, you know, you'll see one pattern is like toExternal. Right, here's the string thing that a human being might be interested in, but it's not what the code cares about. Arrays, don't use arrays, right? Because arrays break you for other reasons, as you know. If you design it with the expectation that array is only going to have 10 elements in it, then tomorrow somebody comes in and you go, hey, I've got to put 1 billion in. You just don't have memory for it. Right? You can use streams. Java streams are incredibly powerful, and there's even new stuff in streams that's worth looking at right now. But streams stop you storing large amounts of memory, except for when you need to. So you have a stream. APIs produce streams. Streams are things that you can apply the filters to, the mappings to. So it makes it a really simple thing to return data in a stream form. Everything's there for you to use. It's not hard to do, right? And with this idea of people ask you, you give them data, right? They can then use streams and provide all the mapping and the filter stuff. It's so much easier to write code that way. You don't need to have lots of horrible classes and abstract methods and things like that. Right? Right. If you do want to return a collection, if you have no choice and you have to return, then remember to make it immutable. It's not perfectly safe because people can still fiddle with the objects inside, but at least you have some protection. Right. What else we got? Booleans. I have a Boolean, on or off. Oh, okay, I want on, off, and pending. Right, same thing, right? Right. If you're going to do things like that, use enums. You can put all of the magic logic you round about the state of these things. But if you use an enum, you control the range of values and you can extend it. Right? You don't need that Boolean and it doesn't cost you. Performance-wise, compile time-wise, we have all that sorted. Now, the other one is you see is method signatures getting stupidly long. Right? So you might have a get page, you know, what's the page number, how many do I want on the page? Okay. And then somebody says, well, I want to put some code in. I want some filters. I want to put it in reverse order. I want to limit stuff. And so suddenly your get data method gets longer. Of course, version 2 doesn't look like that. Version 1 looks like that. Version 2 is a new method because you know you can't change that one. So now you end up with a whole string of methods that get created as you keep changing them. And they keep having different sets of parameters, and then you have to validate whether that set of parameters is okay. Okay. You can create an interface. Here's one called page config, which is sealed. And I'm going to control what classes implement it. And this time I'm going to use records, because records can implement interfaces, right? So now what I've got is I've gone from get data page I now have get data page config, right? I don't need all of this extra parameters. Every time I want to add parameters, I can create a new record with the new parameters, which I can validate. And the method that I'm using to call the data stays the same, right? It's just get data with the page config. Right? You can use records in those sorts of ways. And if you use this inheritance thing where you implement an empty interface, you get control of this. People can't fake it out. It's still in your control, but your API doesn't need to change when you move to the next version. Right. Okay, so I think I've said that. There are other things you should think about, which is when you create methods, when you create a class, every method you declare for the first time round, the public ones, that's all you can do. Because anytime that you have a class that can be subclassed, anytime you add new methods, you run the chance of clashing with methods the user's added on top. So your API space for a class is really tiny. Okay, right. What else we got? Well, I think I've said this. Let me skip over a couple of these things. So the way to think about this is, yes, certainly for small classes, use constructors. For larger classes, look at using the builder pattern because you can describe those interfaces. You can build generic, you can build basically little DSLs with inner classes. It's, once you get your head around, it's really easy to do. That's your API, right? And that's much more flexible than a constructor. And it's much more flexible and safer than having a constructor and then telling people what order to call methods to set it all up. Yeah. So these sealed interfaces, sealed classes, let you do this separation. You can really separate out your code from your user code. You can hide everything. It's really, really powerful. Right. Yeah. I think I've said this sort of, but I hope you get this, which is use the types that are available to you. Don't use the primitive stuffs. Right. Okay. And if you can, stream. Right. Streaming reduces memory usage, but it also helps you enforce this consumption pattern. Right. You want the pattern where your API user calls you to set up a policy for what it wants from you, and then you give it back to it. And if you do it in streams, all their code can be here dealing with that stream. Right. Yeah. So I think that's what I really said. Complexity is in the builder. That's where you put it. That's your API. Yeah. Okay. Ta-da! So there we go. What have we learned? Semantic versioning is broken, not intentionally, but through, I don't know, through history. Generics are great, but be cautious of the fact that they help you as a developer. They're not going to help you at runtime. Compiler and runtime are not quite the same. Go read the Java compiler spec, and the JVM spec, right? If you don't have a way for catching, if you don't have a V1 testing strategy to catch the changes that you've injected, if you don't have a binary testing strategy, you will break people every time because the IDE and the restructuring and what the tools give you, they're so good at helping you miss the fact that you've broken your end user. Okay? Don't use primitives. All right, except for when it really is a number or a string, okay? And there's a whole bunch of modern APIs out there features in Java that we don't use that absolutely can help you do your job better, can help you get performance, and help you create more robust APIs. There we go. Thank you.